right, so last class we left off in 3.2. We didn't finish 3.2, so we'll go ahead and do that today. And then we will go to 3.4. Remember, you guys aren't held responsible for 3.3. So we'll go ahead and start in 3.2. Before I write that, let me write this. All right, so that says approximately 68% of the data is within one standard deviation. I just SD for short, one standard deviation of the mean. The other two will be written in the same format, approximately. All right, so approximately 68% of your data is within one standard deviation of the mean. 95% of the data is within two standard deviations of your mean. And then 99.7% of your data is within three standard deviations of the mean.
Sir, what does that mean?
We're not finished yet.
Oh, thank you.
I was just giving everybody a chance to write down what I wrote before I scroll up.
Oh, thank heaven. I'll mute myself.
All right. All right, so now I'm going to do a diagram to show what that means, and then we'll actually do an application. I may need more room. Let's do this. All right, so here we have our normal distribution. We talked about normal distribution before. We have our mean, which is in the middle. I didn't rewrite that. Mu, Greek letter mu, is our mean. Greek letter sigma is our standard deviation. And so we have our Greek letter, well, we have our mean, excuse me, in the middle. And so according to the empirical rule, if we go out one standard deviation, that's add a standard deviation to the mean, subtract the standard deviation to the from the mean, you will have 34 and 34, which is 68% of the data. Notice the bulk of your data is surrounded by the mean, and then it spreads out as you move away from the mean. If you were to go two standard deviations out, so you're talking about adding two standard deviations to the mean and subtracting two standard deviations away from the mean. Remember, our standard deviations helps us to measure the spread of data. It gives us our positioning. How many standard deviations are you away from the mean? So that's what we're looking at. So if you go two standard deviations away from the mean, that will be 95% of your data. In other words, if I were to add 13.5, 34, 34, and 13.5, that will give me 95% of my data. If I were to go three standard deviations out to the right and to the left, that would be 99.7% of my data. And then if you were to add up all of these percentages, 0.15 all the way over to the other 0.15, add up all of those, you will get 100% of your data. It's symmetric about the mean. That means 50% is to the right of your mean, 50% is to the left of your mean. So 34 plus 13.5 plus 2.35 plus 0.15 will give you 50%. And that'll be 50% on both sides. So that's how your normal distribution works in reference to your mean. It is symmetric about the mean. Questions on anything I've written before we actually use this information? We also, once we put in those data values, we also can, I'll wait until we put some numbers on it and then you'll see. I'll wait till you put numbers on it. All right. Scrolling up, let me know if I shouldn't. Is everybody all right? Okay. All right, so the mean IQ score of students enrolled at University A is 100, and the standard deviation is 16.1. First question, determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. B is determine the percentage of students who have scores between 67.8 and 132.2. And I'll do one more, determine the percentage of students determine the percentage of students who have scores above 132.2. All right, so I'm gonna scroll up a little. All right, so our mean was 100. And also don't forget notation. If we were dealing with a population, I mean not population, if we were dealing with sample, you know, we would use X bar. So don't forget your notation. So we could use mu or use X bar either way. And then here, standard deviation 16.1. But if we were looking at sample standard deviation, we use S. So depending on the context, you know, your symbols could be mu or X bar, or for your standard deviation, it could be sigma or S. So this is for population. All right, so now let's go up. I'm coming right back down, but I want to show you something. If you notice on this left side of the mean, we're going to subtract. On the right side of the mean, we're going to add. So that's how we would calculate and fill out this chart. Start with the right side. Doesn't matter which side you start with. But if I go mean plus my standard deviation, that's 100 plus 16.1, which is 116.1. Then my mean plus 2 standard deviations, that's 100 plus 2 times 16.1, which is 132.2. And then the mean plus 3 standard deviations. So it's 148.3. Left side, we're going to subtract. It's going to be 83. So we got 1.8. 51.7. So those are our three values on the left: 83.9, 67.8, 51.7. Then on the right, 116.1, 132.2, 148.3. Questions on how we got those values before we go to the application of those values. Or you'll start in the middle with your mean. Your mean is in the middle. You're going to add a standard deviation 3 times. And then to go to the left side, you will subtract the standard deviation 3 times. All right. So let's go back to that empirical rule chart. Start in the middle with our mean, which is 100. To the right of it is 116.1, 132.2, 148.3. To the left, I want to make this red. To the left, 83.9, 67.8, 51.7. All right, percentages stay the same. So those numbers at the bottom will change, but the percentages will always stay the same. The percentages are a part of your empirical rule relationship. All right, questions on anything so far? So with the way it's set up, you can lean on your empirical rule as far as those three statements that was given, or you can look at these percentages. You can see that between 83.9 and 116.1, that should be 68% of your data. That's just adding up your pieces, 34 plus 34. Or if you want to say how much or what percentage of the students will we expect to score in between 116.1 and 132.2, that would be 13.5% of the students will score within those within that range. So that's how you can use the empirical rule. You can use it to predict weather. You know, if you had enough information on what the weather normally is on this day or that day or something like that, you can use it in the same fashion. So, excuse me, different applications for it. So let's go back to question A. Determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. Well, this one, whether we filled out the chart or not, we wanted to know how many students would have IQ scores within 3 standard deviations of the mean according to the empirical rule. Well, according to the empirical rule, that would be 99.7%. And that didn't have anything to do with our chart. That's just generally. According to your empirical rule, if you go all the way back up, approximately 99.7% of your data, 99.7% of your data will be within 3 standard deviations of the mean. So that's where that came from when you talk about A. All right. Questions on A? Okay. So B, determine the percentage of students who have scores between 67.8 and 132.2. So 67.8 is right here. 132.2 is right here. All right, is that a question? Sorry, I'm here to Wi-Fi again. So oh, it's all good. Someone sent me a message. So 67.8 and 132.2, all you would do is add up the data values. Even if you don't remember the relationship that empirical rule set up, you can add up your percentages, and B would be 95%. Also, the empirical rule states generally if you're within 2 standard deviations of your mean, it would be 95% of your data. So that's another way you could have done it. And then last one for this problem, C, determine the percentage of students who have scores above 132.2. So you're talking about above 132.2. You're over here to the right of 132.2. So you're gonna add the 2.35 and the 0.15, and that'll be 2.5%. Questions on how the empirical rule works. Some questions may not show up until you actually try it out. So as always, try it out, see if you get stuck. And I think what I'll do, I'll see you in a second. Anyway, try it out, see if you get stuck, and then we'll go from there. We need to do another one, we'll do another one. All right. So let's look at, that was it for 3-2. Let's look at 3-4. At least start it. All right, so z-score is going to be the distance the data value is from the mean in terms of standard deviations. So the way you would calculate it generally is that you have your data value minus your mean over your standard deviation. Remember we talked about before how your symbols may change according to being in population versus being a sample size or being a sample. So if it was your population, it would be X minus mu divided by sigma. If it was your sample, it would be X minus X bar divided by S. All right, so after you do your conversion and it converts it to a standard measurement, which is that z-score. After you do your z-score conversion, it's considered unitless, and then the mean is going to be 0, and your standard deviation is 1. So we're not talking about when you're plugging in. We're talking about after you calculate it, and you'll see what I mean as we actually get into the application. If I'm not mistaken, this section only introduces the z-score. We really don't get into the application until I think chapter 6. So right now we're just looking at how do you find your z-score, not the application of z-scores. All right. All right. So we want to determine whether the Angels or Rockies had a relatively better run producing season. The Angels scored 773 runs and played in the American League, where the mean was 677.4 and the standard deviation was 51.7. The Rockies scored 775. Whoa. Sorry about that. Not 775, 755. Scored 755 runs. Played in the National League, where the runs scored was 640. The mean was 640, and the standard deviation was 55.9. So we want to see who had the better run producing season relatively, and that's relative to the league that they played in. If you know a little bit about baseball, then you know that the American League has a little bit different rules than the National League, so it does matter. All right, so first thing we'll do is look at the Angels. Look at the information for the Angels. So they scored 773 runs, so that's going to be our data value. That's the one we want to convert to a z-score. The mean, 677.4. Standard deviation, 51.7. The Rockies, they scored 755. Average was 640. Standard deviation, 55.9. All right, so to calculate the z-score, we do 773 minus 677.4 divided by 51.7 for the Angels. And that should be 1.85. And for the Rockies, data value 755 minus 640 divided by 55.9. That should be 2.06. Also, it's going to matter later. We always want to round our z-scores to 2 decimal places. All right, so we're comparing our z-scores. And what this means is that Angels All right, so looking at our results, the angel scored 1.85 standard deviations above the mean. If it was negative, if our z-score ended up being negative, that means they scored whatever number below the mean. So above and below does matter. So the angel scored 1.85 standard deviations above the mean. The Rockies scored 2.06 standard deviations above the mean. So that means the Rockies had a better run producing year. And so that's how you would use your z-scores. Questions? Any questions?
I do.
Uh-huh.
Is there anywhere I can find some help using this darn calculator?
Get with me on after class.
Okay.
All right. All right. Let's see. All right. So let's look at percentiles. Percentiles. So the K percentile, just using K just generically. The K percentile of a set of data is a value such that K% of the observations are less than or equal to the value. And Kth percentile is denoted by P sub K. All right. So what does that mean? All right, so Jennifer just received the results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean? Okay, so what it means, oh, all right, so what that means is that 74% of the people who took the exam scored 600 or less. Remember, her score is 600. So if it's the 74th percentile, 74% of the people who took the exam scored 600 or less. 26% scored better. So you would just take that 74, subtract it for 100, and you would know how many people scored better than her. Any problems with interpreting percentiles? All right. Time this class better. 15. We got plenty of time. Last thing in this section, I believe, quartiles. All right, so your quartiles, they're just values that divide your data set into fourths. So we're looking at quartile 1, 2, 3, with your max and min being book ends. So we're looking at quartiles 1, quartile 2, and quartile 3. They'll split up your data into fourths. Oh, no, 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 no.
Mr. Tucker,
Mm-hmm.
I do have one more question. I know you said meet with you after class, but is it possible for you to like with the assignments, um, like for my quantitative reasoning class,
Mm-hmm.
instructor would like give us a little, um, she would put she would post a little sheet for us how to enter the functions on the calculator.
That's why I said meet with me after class because everybody may have different calculators,
Okay.
and I would just address everybody individually.
Okay.
So that's for everybody. Anybody that want to get with me after class about their calculator specifically, then I would just talk to them on an individual basis, and then
Okay.
just go from there. So yeah, yeah. So that's why I said me and you can
Okay.
talk, because your issue may not be the next man's issue when it comes to those calculators. They can be a little funky at times.
Okay.
Yeah. Cool. 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 All right. So finding your quartiles. First, you want to list your data values from least to greatest. Then we're going to find Q2. Q2 is going to be the median of the whole data set. It'll be the median of the whole data set, your middle value of the whole data set. Remember we talked about medians before. Now Q1 is going to be the median of the first half of data because remember Q2 is going to split it in half. So then you have your first half of data. The Q1 would be the median of the first half of data, excuse me. And then Q3 would be the median of the second half of data. All right. As a matter of fact, what I'll do is show you the other things, and then we'll do all this stuff to a data set. Let's look at inner quarter range. So your inner quarter range, IQR for short, is the range of the middle 50% of the data set. Q3 minus Q1. Then last thing, and we'll apply this stuff. I'll probably say greater than. Greater than. All right, so checking for outliers. Outliers are extreme values in reference to the data set. So it could be very, very small or very, very large. We have these fences that we can create or calculate that will help us to determine if we have an outlier or not. Your upper fence is going to be Q3 plus 1.5 times the IQR. Your lower fence times your IQR. So if a data value is greater than the upper fence, then it is an outlier. If a data value is less than the lower fence, it is considered an outlier. All right, so let's do an example that applies all of this. I'm gonna go ahead and write this from least to greatest. So I probably didn't have to write data set up here. Let me do this. I'll put my 802 over here. All right, so we have 180, 189, 370, 618, 735, 802, 1185, 1414, 1657, 19. That should be 53. That really didn't matter that much, but it's okay. 1953, 2332, 2336, 3461, 4668, 6751, 9908, 10,034, 20,000, 21,147. Okay, so I wrote it like this. If I had a long enough page, I would have wrote the first half of data over the second half of data in just one line. So it's my first half of data, second half of data, 18 data values altogether. So that means there are 9 values up top, 9 values down bottom. Well, 9 values in the first half of data, 9 values in the second half of data. Remember, all that matters when you're trying to find your medians.
Is
Because
this
if you,
stem and is this the stem and leaf concept?
no, we're going to find the medians of the data set.
Okay.
So all we want are middle values. And so what I mean by that is when we go back to Q2, because that's the next step. Step 2 is to find Q2. That's just the middle value of your whole data set. So if I have 18 data values, that means since it's even, I don't have a middle value, I would take the 2 middle values. So that would be this and this. Those 2 values in the middle. Now, if I had, let's say if I had 21 data values, then I would have a middle value. Remember, that's how we would find the median. If I had 21 data values, then I would be able to do it. But since I do not have an even number, then I would take the 2 middle values, add them together and divide by 2. And I should get 1805 for Q2.
I'm just asking because I'm trying to work these as you do them to see if I'm going to get the same answers.
No, you're fine. You're fine. So remember, we're once again we're trying to find our quartiles, and our quartiles are just medians. All they are medians, middle values. Now to find Q1, we want to look at the middle value of the first half of data. That's why I split it up into first half and second half of data. In other words, I had 18 values, so I had 9 values up top, 9 values in the bottom half of data. So the middle value of my first half of data would be 735 because I have 9 data values. That means I do actually have a middle, and that would be 735. Finding Q3. That's the middle value of the second half of data, which is 4668. Finding the IQR. IQR is, no, we're using this one. Is Q3 minus Q1. $39.33. All right, so remember we had an upper fence and a lower fence. Upper fence is Q3 plus 1.5 times the IQR So that's 4668 plus 1.5 times 39, 33. So if you have to do this according to order of operations, you can't just put in your calculator this way. You do 1.5 times the 39, 33 first, which would be
58.99.
Yep, you got it. And add that to 468.
10.667.
Mm-hmm.
George, I think we got it.
Ah. All right. So the lower fence, Q1 minus that 1.5 times IQR. So that's 735 minus 1.5 times 3933. This is going to end up being a negative value. All right. So before we finish it off, questions. So we did all of the things that we mentioned. Once I started talking about quartiles, we found quartile 2. The first thing we did was listed the data values from least to greatest. Then we found quartile 2, found quartile 1, quartile 3, found our IQR by doing Q3 minus Q1. Now we just found our upper fence and lower fence.
How did you get the negative value?
If you do 735 minus the 5899.5,
I don't do I don't do the 1.5 times the 3933 first.
Yeah, and that's how we got the 5899.5.
I did it that way. Mine didn't come up with a negative.
So now okay, so how did you do it?
I did the 1.5 times 3933.
Uh-huh.
And then I took the sum of that and subtracted 735, and I came up with 5899.5.
Okay. So now if you do 1.5 times 3933, you get 5899.5, right?
Right.
Okay. So now what you have to do is put it in the calculator in this order. See what I mean? If you
I
put it
did
in the calculator like this,
64.5, but no negative sign.
so that's what I'm saying. Did you do it? Did you do it like I do it in like I have it in red? Did you do 5899.5 minus 735?
Yep.
And that will give you a positive. You got to do 735 minus 5899.5.
Yeah.
All right. Oh, excuse me. Excuse me.
Yes.
Thank you. All right. So the last thing that we have is, are there any outliers? So if we have any values greater than this one or less than this one, that would dictate or tell us that we have outliers. Those are our fences. So go back to your data set. We don't have anything less than, because we have a 180. And remember, we dealt with that fence was negative. So we know we don't have anything less than, but we do have this 21,147. And that 21,147 is greater than the 10,567. And that would be how you would do it. And that is because so that is an outlier. because it is greater than the upper fence.
Easy peasy.
Say it again.
Easy peasy.
Oh, okay, sounds good to me. Sounds good to me. Any questions or concerns before we close out? So next class, 3.5. That will be all that we'll do, and that will close us out of chapter 3. So we'll be done with chapter 3.
Did you grade the definitions?
Yes, if you sent them to me, did I if you sent it to me, did you give me or did I give you a
I
response?
I went on my stat lab
Hmm.
but I opened a Google Docs on and copied the questions and pasted them on the Google Docs and I shared it to you.
Okay.
It's
Did you
all
get a
together.
did you get a response from me?
I don't think I did.
Okay. I'll check my emails. I might have missed you.
All right, because I couldn't share it as an attachment. I had to I couldn't email it as an attachment. I had to share it to you.
Okay.
And I put chapter 1 and 2 together.
Okay. And you didn't pop up who's talking. Who's whose name should
Asiana
Adriana. Okay, last name?
Cunningham.
Okay. So I know what name to be looking for in my emails. Okay,
Okay.
I'll check it out and look to respond back to that.
All right. If I gotta send it again, I will.
Okay, not a problem, not a problem. Sounds good. And anybody, if you haven't sent those to me, go ahead and get those to me so I can give you credit for them. You don't want that easy grade to be a 0. All right. So anything else, anybody else before we close out? All right. So you guys have a great day. I will see you all on Thursday.
I'm staying after.
No, nope, I'm closing out. I'm closing out.
Last you go over to go now.
Hold on 1 second. Oh no. Hello?
Hello.
Okay. No, I'm having a problem with this thing. If I wait for the response, if I have to close out, I'm gonna come back. Oh no, I'm back in here now. Okay. It was just acting weird. But I am trying to stop the recording and then I'll answer your question.
I've got 3 Zoom sessions going.
You probably messing up my Zoom right now.
Oh no. It's Zoom because they're having trouble in there too.
Okay, cool. I thought it was me.
Mm-mm.
Um,
Entire world doing Zoom right now.
yeah, you're right. If for some reason we have to close out, we can always meet again. It's not a big deal. We got to set up a separate Zoom time because I need to see your calculator. Just to see a screenshot of it. But right
'Cause
now,
I'm losing a lot of study time trying to deal with this calculator. Because
yeah.
like I already started on my homework assignments, and before it gets to the actual problem solving assignments,
Hmm.
I need to be able to master this calculator.
Right. I got you. Well, I'm trying to make it so that I can see you. I can't even.
Oh, it might be. I don't have it. You know how I roll. I sit here with a baseball cap.
Oh no, no, it's not you because Zoom keep freezing up on me. I can I can hear you, but I can't see you guys anymore. And it keeps saying that it want to close out, and I'm trying to prevent it from doing so.
Well, there's only us in here, so I guess
Yeah.
everybody else is gone.
Oh, everybody else is gone?
Yep.
Yeah, see, the last time it put me back on, which was a few seconds ago, I saw about 6 or 7 people.
Can you see me?
Not yet. I'm trying to wait for it to bring me back.
minimize your Zoom screen and bring it back up. That's what I normally do when it freezes up on.
All right, so right now I can't. Let's see if that'll work. No. Can you see me? Hello?
I can't see you.
Yeah, okay. Um, hmm.
Maybe try
Huh?
stop your screen. Maybe
Said it again?
stop sharing your screen. That might help.
Well, that's what I've been trying to do, isn't froze out on me. So this is what I'm gonna try to do. I'm gonna close out, but I'm gonna open up this sharing. I'm gonna open up the Zoom back because right now I can't see anything.
Okay.
And then so give me like 2 minutes,
Okay.
2, 3 minutes to close out, and then try to log back in and see if it'll let us get back in. If not, we'll just have to maybe set another Zoom session maybe later on this evening or something where maybe everything is slower. Hmm?
Damn, I need to fix right now.
I'm sorry I didn't do it.
Maybe cancel recording.
Yeah, that's what I'm trying. I'm trying to do that. So I'm gonna try to close it out. And if we get kicked off, I'm gonna kick back. I'm gonna get back on, and you can just get back on as well.
Cool beans.
All right.